Hi, it's Commodore Sam coming to you again from LA, Lower Alabama. We've got our second installment of our Prog8 programming series today. Today, Andrew's going to take us through a program that comes out of the Commodore 64 User's Guide and convert it into a Prog8 program. Show you how to, point out some of the language features and the differences between it and BASIC, and kind of get a feel for the Prog8 language. We, of course, will get more in depth as we go along, but this will give you a real taste beyond the Hello World application that we did last time. So sit back and enjoy.
All right, so today we're going to talk a little bit more about programming in Prog8. Last time we talked about setting up the integrated development environment on Windows, and we're going to just go over a small program. In this case, it's coming from a basic example and showing it converted to Prog8, and talking about sort of the elements, like the variables and etc. of the Prog8 and the basics as well. So first, I'm going to clone it from a repository on GitHub, and that is publicly available, and it has the basic program and the Prog8 that I'm going to go over, so people want to check it out themselves. Same as we did in the Hello World example, we're just going to pull it from GitHub. It's on my GitHub. And it's just Prog8 users group repository, which is going to have all of these lessons, as I was referring to them, on there. So this is just going to be the first one. So once this clones, it's going to open the project, and it does a little bit of indexing of the files as well. But I will start showing you here some of the related files once this is done here. Okay, so in lesson 1 we have this PDF, which is the game from the Commodore 64 User's Guide. So it's on page 51, and it's a simple number guessing game where essentially it asks you for a number, and then it or a limit, and you say, okay, 25 or 100, and then it guesses the number or picks a random number within there, and then you have to guess the number. And if you're used to, computer science things, you'll do like a binary search to find it. But this is the basic program that we're going to, talk about here a little bit. So I will run it real quick just to give you an idea of how it looks. It's pretty straightforward. Got it in the make file here, and we can just run this run basic target, which is going to just launch Vice with the number guess program. So here's Vice, and it's asking me, what's the upper limit for the guess? Okay, the upper limit, we're going to just pick 100. And it picks a random number in there. So I'm going to just pick 50. And it says, hey, my number's lower. So I'm going to just, keep guessing. This isn't a proper binary search here, but it basically you just keep
Can
guessing.
you get it before you scroll off the screen?
Yeah, I was going to hope to. But all right, it's 19. Do I want to try another? No. So if we look at this program here in BASIC, if I can type. Essentially here we're, printing this here to clear the screen. Then we just give you a prompt and ask for a number, which goes into the variable L. Then we use that, or Li, it's off the screen there. We use Li with a random generator, so we get a number between like 0 and 1 random, multiply that by your limit, which never really gives you 1, so it's always going to be lower. It gets converted to an integer, so it's going to be like from 0 to 99, and it adds 1, so now your numbers are between 1 and 100. And then it keeps a count of like how many guesses have you done, and then it says, hey, I've got the number, prints that out, prints an extra blank line, asks you, what's your guess into the variable GU. It increments the count, which is the number of guesses. And so, you've entered a number. It is if the number is greater than its number, or your guess is greater than its number, then it'll say, hey, my number is lower than yours, and then go to 30, which jumps back to asking for your guess again. And the same thing for the other direction is if your guess is lower than its number, it says, hey, my number's higher, and then jumps to 30. Well, if neither of those are true, then it is equal, which means you've gotten the number, and then it prints out the count, which is the number of guesses it took you, and then asks you, do you want to try again? And it does a get AN string, which is going to get a character from the keyboard. And so if you don't type anything, it's going to go to 80. So it's going to basically, wait until you type something. And then if it's a yes, it jumps to the beginning where it clears the screen and starts over. And if you don't say no, okay, so if it's not no, it jumps back to 70 to ask you again. So if you say yes, it'll restart. And if you don't say no, then it will also ask you again. And so then if you did say no, it falls through and you're done, right? So it's basically, nope, too many letters there. He comes up with a number, you guess, you keep trying to get, the number, and that's it. And so this was a pretty simple idea, but it exercises some of the, many things going on essentially with reading input, doing text output, getting a number, which in BASIC, it kind of handles that and then you can convert, it gets a float and then you can convert it to an integer. All of that you have to kind of do via function calls in Prog8. So now that we looked at that, we can do a quick run of just the Prog8 version of the same functionality, and then we'll go over the source code or the programming a little bit, details for Prog8, and then the source code for the program itself. So here we are. This is a Prog8 version, which it has a different color scheme that it picks by default, which we can change, but I didn't. I did have it use, we're in lowercase mode instead of all in uppercase. So we'll say, like, okay, I've got my number. I'll say, okay, do a little search here. Whoops, I meant to type 18. We'll say 15. Hey, you got my number and only 4 guesses. So we'll say no. So there's, a Prog8 version of the thing. Essentially, behaves the same, looks slightly different. And we can bring up the actual program here. Rid of some of this extra stuff on the screen. And we can go through this, but then there's a few of these that we need to go kind of like some foundational things, which I was going to go over first. So we'll just know that, here's this file main.p8, which is a Prog8 module. And then I'm going to switch back over here to this Prog8 documentation and talk about just that portion of it a little bit. On our last video, we talked about compiling Hello World, getting our compiler installed, and all of that. So here we're at the sort of programming section. We have a bunch of different elements of the program, but we're going to, and capabilities, language capabilities, but we're going to just talk about kind of the beginning, which is, what is a program? Well, it's made up of one or more modules. And in this case, the modules are, a file. So a file with a P8 extension, which has directives and code blocks, various white space. A file can import other modules, which, uses as a library. And it mentions that it should be saved in UTF-8, which, is what your modern machine is generally going to do by default. Mentions comments, that everything after a semicolon is a comment. You can do comment blocks with /* and // like with C. Directive is an instruction to the compiler, which we have a couple that we're going to mention. A code block is a section of code, and it's mandatory to have a main block and a start subroutine, which we'll mention subroutines down there. Variables will, we saw count, number, guess, etc. in the basic program, and we're going to need to have, similar variables. So talk about that a little bit. There was like if the guess is higher or lower than the number, and there was a call to random. So we have some subroutine calls there that we need to do, and then we're going to have some if statements, etc., like to check the number that you guessed. We're using subroutines just because of structuring it maybe a little more modern, less of like the go-to jumping, which is done in the basic program. Labels, we could use go-to with labels, similar to the way basic line numbers work, but we're not really doing that. And then this talks about the scope, which is really like subroutines. Like the scope is within a block, and so you can have a function within a block or a subroutine in a block, and you can have, like main.start is the start subroutine. It's within the main block, and that's kind of like the scope of variables and things are within main or within another block that you create, which we'll go over. But we have identifiers, which are about like the things that you name, like subroutines or blocks or variables. It takes like Unicode. So here's some things that I wouldn't know how to quite type on my keyboard, but it can be used for various names. Here's a mention of the scoped names, like main.start or a variable in the subroutine main called main.start.variable, which we have main and start, and then we'll have a couple. We do have some variables. When we talk about blocks, the block name, for example, the mandatory block is main, and then we will have, curly braces to delineate the block, and within there we're going to have a start subroutine and a couple others. So we're going to have that part, and here's a bit of an example. But what we want to talk about is variables. So we're going to jump to variables real quick. And variables, when they're declared, you give it a data type, and we have data types down here of like string or unsigned byte or ubyte. They've recently added long. We have byte and word. So a byte, of course, is a 256 byte value. It's actually signed, so it's like 127 to minus 127. Ubyte is unsigned, so it's 0 to 255. Word is a 16-bit value, and uword is unsigned 16-bit value. So bool is a true/false type of flag, etc. And this talks about the variable definitions. We're gonna just use some straightforward variables, which I'll show you here shortly. There are also some extra flags for like if you want your variables to be in 0 page or to prioritize putting it in 0 page, or it has to be in 0 page, or don't put it in 0 page. We're not really going to use any of those, but there are a bunch of extra things involved with declaring a variable. So that's sort of the base level of what is a program. So let's look at the program again here a little bit more. And we can actually bring up the guessing game, like the original BASIC here, a little bit to the side. What we're doing here is first, this is a module, so it's main.p8, and we have some directives. So the 0 page directive says, how do you want to use your 0 page? In this case, basic safe means I would like to not touch any 0 page that basic needs, which also would mean the kernel, and be able to exit cleanly back to basic when my program ends. So without having to reset the machine. So in setting this, when I say no, like, do you want to do it again? And you say no, then it exits back to basic, which is what the basic program would also do, of course, because it's in basic. Percent import, or import, is pulling in other modules. So in this case, we need the conversion module, or conv. We need some math for like random. So we're importing math, and then text IO for printing and reading some input. And then we get to our block. So main is the mandatory code block. And then within there, we have the mandatory start, which is the entry point of the program. But within the main block, I'm defining some variables. So we have a string variable. It's called temp. And in Prog8, these variables are static. They're not dynamically allocated. So whatever you define this size to be when you start, that is going to be the size for that variable forever, which means it's easy to overflow it if you don't keep track of what size it is, which I actually made this 8 on purpose. So here we're going to ask you for a number, and your number should be between like 0 and 255, because we're dealing with bytes here. That would be 3 digits plus like a 0 null termination. But you could actually type a whole sentence because it's using the Commodore 64 screen editor to get that input. And so if you type more than 8 characters, this will actually overrun and cause a problem. So I listed this here as just sort of an example of it. It's like, okay, I only need 3, so I'll just make this 8. But in fact, people can type anything, and rather than checking that and doing some error checking, your program would actually just crash. But meanwhile, the maximum a person can enter, I believe, is going to be 80 characters, like 2 lines, which is, like the basic. So really, this should be 80 to be safer. But then, of course, it also occupies, 80 bytes in your program. But you were predefining this temporary string. This is where we're going to ask for something from the user, which is we're going to ask for the limit. We're going to ask for guesses. And do you want to try yes or no? Or, do I try again, yes or no? And so we need a temporary place to put that, input. In the basic program, we stored the limit as LI over here. We stored the guess as GU, and then here was AN $, which is the answer. So we have equivalent variables, but basic is automatically handling the type for you, more or less. And so you're getting a number in this case, and it's a float, it's converting it and all that. We have to do that in Prog8. So we have a temporary string to get input, and then we're going to have the actual variables, which are the numbers. In this case, they're U bytes, so that's an unsigned byte or 8-bit value, 0 to 255. And we have the count, which is the number of guesses, what your guess is, the limit, which is this LI variable, and then the number, which is the computer number that it picked from within your limit. that you're trying to guess. And so those are the same variables as li, cn, gu, and let's see, li, cn, gu. Where's my guess? And oh, nm. There we go. I was like, where did my guess number go? nm is the number that the computer selected. So now that we have these variables defined, we're going to see what happens when we enter the program. So first thing we're going to do is switch to lowercase mode. It just looks better, and it's a good, modern thing is to have the mixed case. And so as this example, I was showing it that way instead of all uppercase. Then this thing is a game that if you say yes, it's going to do it again and, forever. So if you just run the game, say yes, I want to try again, it'll run forever in a loop, essentially. So that's where I did here is created a game loop, and there's a directive called repeat. Repeat usually can take an argument like repeat 12 times or 100 times. In this case, if you don't give it a parameter, it will just repeat forever. And so this is, in effect, creating an infinite loop. And it could be the same as, putting a label here and at the bottom of this saying go to label. But it just does this loop forever unless you break out of it. So because when the game starts, it's going to drop in, or if you restart the game, it's going to start back here at the top of this repeat loop. What we're going to do is we're going to initialize all these variables again to 0, so that after you've been playing, if you start a new game, everything starts out at 0. And so you can see, like, the block uses these curly braces to emphasize, the opening and closing of the entire block. The subroutine uses curly braces. So here's from the start to the from the start subroutine's beginning to the end of that routine is these two, and then these loops are also using blocks. And so everything that's happening between these two blocks is just happening forever. So first, we initialize these variables all back to 0. We're calling this text IO function to clear the screen. We're calling a subroutine init, which is right down here. Then we call play, which init asks for the limit, and then play just takes your guesses. And then down here, we have a variable or a subroutine called again, which is asking you, would you like to play again? And you can say yes or no. It's going to return yes if you want to play again, or no, or true if you want to play again, or false if you don't want to play again. And so we're checking that. So if you said, I don't want to play again, so if not again, then we break, which breaks out of this repeat loop, and then it's to here, and there's no more statements, and that's the end of the start subroutine, which is then the end of the program. So this text CLS and text lowercase, these are coming from this import text IO, which is a module. We can look this up a little bit here in the Prog8 documentation. On the left side here, we'll have library routines and built-in functions. So if we click on that, it will talk about there are many routines built into the libraries or the built-in functions. Important ones are in this other chapter. Okay, so let's go to this chapter, and it mentions %import, and then it's basically saying, go look at the source code for the library functions, and then here is a list of them all down the left side. So in this case, we're talking about text IO, which is txt.star. So if we click on that, it mentions that it's for printing strings, reading text input. So we're doing both of those things. Changing the screen and colors, we haven't done that, but we did change it to lowercase. And so it says here, read the source code. So let's open this source code in another tab real quick. And we can just see, there's a lot of things going on in this library. There's a lot of different functions like column, get column, row. What we're interested in is a function called input. And it mentions it right here, input chars, or cars, I guess you could call it. But and if we look in here, it's only finding this one time. So we linked to the text IO and went to the Commodore X16. And this is where I'm just pointing this out because within this module, it's actually importing another module. And so if you want to follow that documentation and find some of these functions, you need to look at this shared function section, because this one is the Commodore X16 and it has like machine specific things, but then this shared one is actually going to have like the common ones, which are things like this input or some print functions. So I guess I should explain what I'm clicking on here. So here we are at this link that we went to from the documentation where it says, text IO. It's in the CX16, and then we want to go up to this Prog8 lib directory, which has the Commodore 128, 64, X16, PET, 32, etc. And we're going to scroll down and look for this shared CBM text IO functions. And this is going to be the one that we're looking for, input cars here. And so here's the function that, and if you read it, it says input a string max of 80 characters. So if we go back to where I was talking about where I define this string, I really should define that as 80 because people could type in that much, and without it, we would have a buffer overflow, right? So if we go back over here and we say, okay, the documentation says 80. So we should definitely put 80 here for the string, and maybe it needs to be 81 for 0 byte, right? So if we go back, then we should, okay, we want the 80 is the max string, plus we're going to have a null byte at the end. So let's go ahead and make that 81 for that temporary string, because we don't want the program to crash. People aren't going to try to type that big of a number in, but we just want to be careful. So anyway, this is a library function, and this was one way of where you would find all the different library functions and how they're documented a little bit here with the comments. This is an area that needs to be worked on a little bit to document more of these functions directly in the source code, or I mean in the documentation instead of in the source code. But this is how it's currently set up. But I just wanted to point out for these shared functions that it's a little bit convoluted to get to functions that are defined in this shared file, versus if you just follow this link, you won't necessarily find what you're looking for, which is, in this case, this input character that we're going to use. So there's that. We'll go back here now.
As a side note, I would.
Yeah.
It was interesting that they're using a lot of assembly in those shared deals to make them faster. But I don't think we've mentioned the fact that you can mix assembly and Prog8 commands together.
Yeah, that's very true. One of the powerful or more powerful features of Prog8 is that you can do inline assembly. So if we go back here real quick to look at this one, and input chars was the one. I mentioned over here, we have sub for subroutines and start, and then I have some other subroutines. Well, these are the Prog8 subroutines, but then an assembler subroutine is an ASM sub or ASM sub, and it has some additional definitions here defining like the type of variable that's being passed in, which we can also have in a normal subroutine, its name, which we also have, but then how it's passed. And so in assembler here, this one is saying that it's a pointer to a U-byte buffer, or it's a U-byte pointer to a named buffer, and it's passed in AY. and then it will clobber the A register, and then it returns a U byte in Y. So this is an extra definition that basically lets you create that binding between an assembler and a Prog8 type of function. And then within here, you do this %asm and double curly brace and have your inline assembler. So right here, just nothing special. You just define it as an ASM sub, or you can just add inline assembler directly in a regular subroutine and, you know, throw your 6502. And then this has full access to variables and other things. So it works, you know, very well for sections that need, you know, speed, like video in this case, or text. Some of it is, you know, optimized outputs. Okay, so we go back over here. We're calling some routines in text, which is like lowercase, you know, clear screen, calling init, play, and then checking again. So if we go to the init, this is where we are doing a text print to ask a question, prompting the user, and then we're reading input characters, which we just looked at. It returns up to 80 character string, and then null terminated. So we now have a text string of, say, the number 25. So we have a 2 and a 5, and we need to convert that string of text into an actual byte, or U byte in this case, an unsigned byte, and get the integer value of 25, not the alphanumeric digits 2 and 5, right? And so if we look at the guide over here, this is asking for a number. The programmer's guide, you know, examples maybe explains some of this stuff more, but in this short little demo here, it's asking for this number, getting the number, it's doing random with it, and then it converts it to an integer, which, because it's basically going to be like a float number, it rounds it and returns it. So we have to do that functionality. So we need to get the number. So we have to ask for a string and then convert that string to a number, and then we're going to use the number. So if we go back to library modules, the one that we're interested in here is conversion and string to U byte. And we don't have to go over that in great detail, but just to find it and to know where modules are. Again, we're back in this library modules and built-in functions. We go to this convert, and it says, you know, see the source code. So it's like, okay, let's open that in another tab. And if we go in here, there's a bunch of different functions that like convert a U byte to a string, convert a you know, U byte to a string with padded zeros, etc. So this is for printing them, basically. Well, we want to actually convert one to a string to a U byte. So that's str to U byte. So we'll just look for that here. And so it says returns in A the unsigned byte value of the string number argument in AY. So this is a ASM sub that we, you know, just mentioned. The inline parameter says to actually just insert this code directly inline as it's generating the code for this subroutine where I'm calling it. And so it takes the string, a pointer to the string, which we have this variable called temp, which is a string variable, and it has up to 80 characters, or 81 with the null terminator on the end. And it's actually holding a 16-bit pointer. It's just the address of the start of this string. And so we're going to pass that 16-bit value to this function. So it's passing a string, named string, in AY. And so this routine is then going to convert that to a byte and return us that byte. So in the example of this game, enter a limit. We enter, say, 25. We have the digits 25 in the string. We're going to call this routine, and it's going to return the integer value, or 25 as an integer instead of a string at that point. So you basically call this, and it, you know, clobbers Y, but it returns A. Well, so you're passing in A and Y, and then it clobbers one of them and it returns it in the other. And all it's doing is calling this string to U word, which is probably, returning it as up to a 16-bit value, but we're only using part of it. So we can scroll right down here, and there's this whole assembly routine that goes through and figures all that out for each digit, figures out the tens place, etc. So we won't go through that part, but that is the function, and you currently have to look through the documentation, which is the source code, to find some of those conversion routines. But there's a whole lot of them in here related to converting from strings to U words, or from U words and U bytes back to strings, etc. So check that out, but it serves our purpose here to just know that we want to call this conversion string to U byte. And so we're going to call it with a variable temp, which is the string. And that's going to return, in my example of, say, 25, the number 25. So now I have an actual, integer number of 25, and I want to do the next part of this routine, which is to generate a random number between 1 and that limit. So if I say 25, I'm going to pick a number between 1 and 25, the computer is, and then I have to guess it. So we want to pick generate a random number between that. And the function for that is this rand range function, which is in the math library. So we can look quick at the math documentation. So we go to math, and there's this is documented in here. We're looking for rand range. So here's rand range U byte n, and it returns a U byte. So it returns random byte uniformly distributed from 0 to n minus 1. Doesn't work in ROM code. Okay, so I don't have ROM, so that's okay. So rand range of 25 is going to give me a random number between 0 and 25 minus 1, so between 0 and 24. Well, I don't want to receive 0. I'm looking for a number between 1 and 25. So what we're doing is we're calling math, we're going to get that number, and then we're adding 1, which is exactly what the basic program is doing here. It's getting this random number, it's converting it to, which ends up being float, converts it to an integer, and it adds 1, which then gives us a number between 1 and whatever limit you ended. So we asked for the limit, we converted that to an integer, we use that as our random range, and we added 1, so it's 1 to the limit. So now we have the limit and we have the number. We print out a blank line, which, just because this input request will end up being right after this prompt, which is how this one works. You can't quite see the 25 here very well, but when you're doing input in BASIC here, where you type is right after the prompt. So that's what happened here. And so once we've gotten that number, we're just printing a blank line so that the next thing we print will start on a new line. And then since we selected the number, we then say, I've got the number. And here I'm showing two ways of doing this. We can call this NL function, which prints a new line. Or when we call print, we can actually do a escape type code, which is common in like C and Python and whatnot, of \n, which generates a new line. In this case, I'm generating 2 new lines. So it goes to the line and then it leaves a blank line. And then the init function is done and returns. So we go back up in this loop, and we call the play. So what happens in the basic is we've done this. We said, I've got a number. And then on line 30, it's what's your guess? So the next thing is to start playing the game, or guessing. And the reason that I put play or organized it this way is because down here, when you guess, it jumps to line 30. And so the kind of the main play loop after your initial limit is from line 30 onwards. And so that's the portion that I've put inside this this play subroutine. So this introduces a new variable here, which is a Boolean variable. It's a true or false, yes or no type of variable. So I have a Boolean called guessed, where did you guess the number, or has the numbers been guessed? And it's starting with false because we're just entering. Then we have an example of a construct that's kind of like a while loop or the repeat loop, but it's a do until loop. So what that says is do what's within the curly brace one time at least, and then keep doing it until this condition is true. So if this condition starts true, it's going to execute this one time and then check it, and then it would fall through. But in our case, we're saying the guess is false, so we haven't guessed it. And, for sure, we're going to go through one time. It asks, what's your guess? Then we use this input characters again to read the guessed number. We're converting the number again, as we did earlier. And then we print a new line to put a blank line on the screen, because if we can see over here, we need to go to the next line to be able to print the response about if the number is higher or lower. And then after that one, there's a blank. So we print out that new line because we can't put it on the end of the prompt, or you would start typing below it when you do the input portion. And then we increment count, which is basically the same as this line 35, the number of times that you've guessed. Then we do some comparison examples here, which are, we're doing an if and then an else if and then an else. So this construct lets you just check values, and this should be a expression that will result in a true or false or a Boolean operation. In this case, we're asking if the guessed number or your guess is greater than the number which the computer selected. And if your guess is greater, then we provide that prompt of my number is lower. If your guess is less, we say my number is higher. And then if it's neither one of those, then you must have guessed it. And so we say guessed equals true. And then it hits the end of the do loop. And then it's going to check this, and it says, oh, guessed is now true. So it will fall out. Or if you didn't guess, then it will just continue at the beginning of the do loop here and ask you again, what is your guess? So we've replicated essentially like lines 30 through 50 and kind of into 60 a little bit right there, but that's basically 30 through 50, where then if you have guessed, it falls through here and it says, great, you got my number in, and it prints out the count. Now, you'll see here, we've printed strings before, which is this print statement. And this is a new print, which is print underscore UB, which stands for U byte. So we want to print a number between 0 and 255, and we're going to use this count variable. So each time through this do until, we incremented count by 1, which is this plus plus. And basically, we want to just print out the count, like how many guesses. So we're saying, great, you got my number in only, and then we'll print the count, and then we'll say guesses, which is basically what line 60 and 65 are doing in the basic. And then we're done with the play subroutine. So then it returns to the loop, and now we're at the if not again check. So this is going to call the function or subroutine again, and then it's going to test the return value from that subroutine, and if it's not true, it's going to break. So we're asking, do you want to play again? And if you say yes, it's true, you want to play again, and it'll continue the loop. I show this is basically kind of inverted, you'd think, because we could call this quit, and then it would be if quit is yes, then break. But because the question is, do you want to try another? I put this, do you want to play again? Do you want to try another? So then the yes would be, yes, I do want to try another. And so that's why this logic is listed this way, is to more closely match the actual question. It would be cleaner, though, to call this function, say, quit, and then say, do you want to play again? And if it says no, then quit returns true, right? So, but this function is called, and then if it doesn't return true, then we break. So we'll go down and look at again here real quick. And this is where we're introducing this return definition. So this dash greater than and bool, we're saying that this subroutine is going to return a Boolean, which means if you don't return the Boolean, that the compiler will complain about it and say, hey, this function, this subroutine is defined to return a value. You haven't returned a value, that's an error. Or if you don't say if you say it's not returning anything by not including this, and then you do return something, it'll give you an error. Works both ways there. So here, this is a repeat. So if we look back at the basic, this asks you if you want to play again, and then if you don't answer, it's just going to, keep checking. And then if your answer is not yes or no, then it asks you again. And that's what we've replicated here with this repeat loop, is just, it's going to ask you over and over again until you either return a yes or a no. So we print the prompt, we get the input, which, previously we wanted numbers, and so we had to convert it. But here we actually want a character, so we're just going to get a string, and then we're going to look at the first value of that string. So once we've gotten the yes or no, or you can either be Y or N, or the spelling yes, or any other word or characters, we're going to then look at it. And so this temporary string can be indexed. And so we're looking at the index 0, which is the very first element in the string, or the first character in the string. And so that introduces this when statement, which basically says, do like a switch or a case type of statement based on the value. And so the value of this expression would be whatever the first character that the person typed on the input, because this is the very first or 0th element of the temp string. So if you type the word yes, it would either be Y in uppercase or Y in lowercase. If you typed no, it would be upper or lowercase n. And so in the when statement, what you do is you list your variable or your values, and you can list multiple by using a comma. So here we're accepting either upper or lowercase y. And then there's what to do in that scenario with this dash greater than. And then we could have a code block which uses curly braces, but for single statements, we don't need to do that. So in this case, if you say, yes, I do want to try another, it returns true. And then if you say no, it returns false. And if you say anything else, the default is neither one of those, and it will just repeat and ask you again. So you're going to be stuck in this loop until you provide either y, or upper or lowercase y, or upper or lowercase n. And when you provide one of those, it's going to then go back to the game loop here. And so if you said, yes, I do want to play again, this won't be true. So it will not, it will be again versus is it not again. So in this case, it won't be true for this test, and it will repeat and start the game over. But if you say no, like I don't want to play again, then it's going to hit this break statement, which is going to break out of the repeat loop and fall through and finish the program. And that's where it exits. And so that's kind of an overview of a basic program which does like inputs, outputs, conditionals, like checking, if this number is greater than that number, asking a question like yes or no, and also, getting a random number, which is a math kind of function. And then we put all those together along with a couple of things like clear screen and lowercase to turn them into a program. And this is a, it might be a little bit of a verbose way of doing it, but it's a, cleanly kind of partitioned up into different functions. It's sort of like initialize the game, start the game, play the actual game. At the end of the game, do you want to do it again? And so, kind of logically divides that up. And then, we have a main game loop, which we just do this forever until you say, no, I don't want to play anymore. And that is, generally what all Prog8 programs are, is a start loop or a start subroutine that, does like a loop or does something and then exits. We'll run this, one more time here. We'll run that again after I made the string up to 81 characters. And so, you could type a lot of stuff here. The other thing is we're not really doing any error checking, if you notice. So I'm not typing any actual numbers here, and we're going to try to convert it. Well, it's going to just take the value of A there and come up with a random number. So it's, if I guess this, I'll just say whatever. Oh, my number is lower. It's a 1. So, there should probably be some error checking and various things, but the basic program is going to just give you like a syntax error, an input error, or some other kind of error. But anyway, there it is running again after we made that slight change to the string size. So there is a working Prog8 program converted from BASIC. Very simplistic. It's just a number guessing game, but it demonstrates a lot of the useful capabilities from Prog8 and the various libraries. And that is pretty much everything that I was going to go over. I will say in the documentation, there's a lot more details to go over about program functions and just sort of the general layout and design of a Prog8 program that, will take a lot to cover all of them. Talking about, different subroutines and the scope, like where variables are within the scope is pretty important. There's aliases. So you'll notice here, like we're doing text print or print UB. You can do an alias that say, instead of typing text.print, you could just have just print or even P or something. PRN is the example that they're giving you here, is like a shortcut for printing a subroutine. And there's a lot more, like for loops. We did the do until and a repeat, but there's a while and a for. For conditionals, we talked about if statements, but there's, if expressions. There's some additional, we did mention the when as well. Go to is possible. We had one sort of variable assignment there where we reset everything to 0, and then I guess the second one we incremented the account, and then when we took input and various things, but I didn't really address that, but it talks about all of that. Expressions are important for the if statement because the if wants to have a Boolean result from the expression. So you can look through, there, all these different functions. But overall, that's kind of like our introduction to an actual program written in Prog8.
Okay, thanks, Andrew. Just for a teaser for the next video, where do you think you'll go from here?
Well, I was hoping to get some suggestions, maybe some comments, some people having some ideas of what they would like to cover.
Those of you that are watching, give him some comments back. Okay.
That's right. I was going to say, I'm not that familiar with like graphics and sound capabilities. It's not really my forte, but there are, like sprite related things that are relatively easy to do. There's some line drawing, there's some various functionality there. then if we wanted to talk about maybe some of the examples that are written in the repo, there's like a Tetris clone. There's a bunch of other different programs in there that we could go through.
Yeah,
I guess
that might be fun, right? Everybody knows the game concept of Tetris. If you don't know, you've never been much of a game player if you don't know Tetris. So that might be kind of interesting. One other thing that I noticed, that maybe some people might that I don't think you mentioned is just line terminations, and in some other languages, if you're coming from some other languages, you may be used to having semicolons at the end, or various other syntaxes, and you really don't have that in this, and you keep one line per, or one statement per line, or
yeah, and that actually
it is covered in the docs, I think. So
I was just saw that in here. Okay, here we go. So under the section of Prog8 versus other languages, it just kind of talks about some differences and maybe some similarities, but it says, hey, it looks like a mix of Python and C. And then what you just mentioned is, there's no statement separator, and there's usually a single line or single statement per line, mentioned semicolon being comments. And so like C would want you to have a semicolon as on the end of each statement here.
mm-hmm.
And then Python would care about the indentation. Well, semicolon is a comment, and we don't need that on here, and the actual indentation, isn't significant either. The white space doesn't matter. It's just statements per line, and it's, readability. Looks funny if repeat and the things inside the repeat loop are all at the same indentation level, but it isn't really required. And if you've seen like the obfuscated code, C code competitions, you certainly can write some, poorly formatted Prog8 as well. But yes, not recommended there. But yeah, the Prog8 versus other languages have some good details if you're coming in from somewhere else and you're not, comments or line endings or different operations you might be familiar with. C, you would always be thinking about linking with libraries and things, and it mentions, there's no linker, talks about data types a little bit. Definitely a good area. And then I mentioned, there's no dynamic, like the strings are statically defined, and this mentions more specifically that there's no dynamic memory management. Variables are all statically allocated. There's no malloc or free type of function. It can be implemented separately, but the operating system or the compiler doesn't provide that.
I want to mention a couple of things. One thing is this Prog8 has always reminded me more of Perl than Python. I know that there's a lot of Python programmers involved in this, a lot more than Perl programmers certainly. But like the sub identifier for subroutines and the blocks and the just the formatting, kind of that's why I like it, because my main program, my main go-to is Perl, so it kind of tickles that part of my brain. But one thing I learned about this that I appreciate you going over, my first, like when I was looking at Prog8 first, one of the first programs I looked at was this animals program. I think you had to guess what kind of animal they were describing, something related to that. But in there, it involved numbers, inputting numbers and then converting it to the printed screen. And I remember looking at how they did that, converted like a number to an actual, or the text input that was a number and converting it back to a number. And it used to be, and I just tried it, and you used to have to access, if you wanted to convert something to a string, let's say like a byte, you had to access, it didn't return the string or the pointer to the string. You had to access the like a global variable. It was like conv, like conv dot and string underscore out. And when I looked at your example, I went and tried it on some of my code, and that's no longer the case, which is really nice because that was kind of a pain to have to do that, to access, to reach in, I guess, to the global variable space and pull out that value. So that was nice. And it looked like also that there are print functions now that will just convert directly, like it'll allow you to print directly just a number or a byte, I should say, to the screen. So that was good that you went over that.
Yeah, and there's a lot of functions in there for converting back and forth, and I know in some of the new work with the compiler on the Discord channel, which people should definitely check out, there was some discussion actually about that very string out or whatever variable. People were like, "Oh, this one is, not returning it in string out because their code that they've had for so long always checks that," and so there was a change. So it's interesting how people use that, but follow the documentation and go from there. Generally, the thing is about whether it looks like this language or that language. I think everybody who's written in any higher level language, you'll find some similarity just because it uses sort of common constructs. And so I think, if you're hardcore, like basic only or assembler only, then it might be a little less comfortable. But if you've done any, high level compiled language, then it should be no problem converting using this. And of course,
I still find myself typing semicolons, even though it's like it's a like it's a comment, everything after. But I'll just out of habit, I'll just have a bunch. I'll look at it, I'll be like, oh, I don't need all those semicolons, and so I'll have to go back and clean it up.
Yeah.
Well, in the
Just
opposite,
don't put a statement after it. So
yeah,
That's right.
anyway.
In the opposite of that, I've found myself not putting semicolons in some C code after doing a lot of Prog8, and then the compiler is very
That
unhappy
will
with
give you
me.
a problem. That can't
Yes.
go the other way. All right. Well, thank you, Andrew, and we'll end our video there this session. Come back for the next session.